Okay, so going back to our tutorial series, sorry for the cough. We are here on C02, and what we'll cover from exercise 00 to exercise 10, exercise 11, and exercise 12 are not actually that important. But you can do again if you want, you just need to make sure you actually know what you're doing. So let's go to our 42 tutorial folder, to our C02. So exercise 0001, 3, 4, 5, 6, 7. Exercise 8, 9, and 10. Okay, so this is pretty boring, to be honest. This is the worst C ever because it's so repetitive. Your hands will start actually hurting if you go too fast from repetitiveness. And trust me, I know this by experience. But anyway, first thing, let's go to our exercise 00 folder. Let's use vim ft str cpy.c. Let's red include std and stdio. And so we have char pointer ft str copy char dest char source. So what do you have here? Here produce the behavior of the function str copy. So we will do man str copy to see what we are seeing. So here's the name, here's the description, str copy. This function's copy the string pointed to by us rc, which is the short form of source, into a string at the buffer pointed by dst, which is destination. The program is responsible for allocating destination buffer large enough. We don't need to actually care about this. The function returns a pointer to the terminating null byte of the copied string. Well, what does it mean? Well, basically, we have our source string, which we want to copy to a destination string with a buffer size. The buffer size, basically, we allocating a certain amount of space for this string to be in. So if we say 25, it will be able to contain 25 characters. If we write like 100, it will be able to have 100 characters. And this pointer right here needs to be terminated to a null byte. So how do we do this? Well, the first thing we need to do is actually know the value of source. So while source is different than 0, we are going to say that the destination of I is just like source of I, and then we increment I. Well, if you don't know what we're basically doing, we are just basically saying that the first character of destination is the same character than the first character of source of I, and while source is different than no, which means while source is not completed, destination will be the same as source. And then on the end we'll say that the destination of I is equals to no, because this is the null byte at the end that the pointer needs to be pointing towards, and then we simply return our destination. So we create our main function here to see if everything is working just fine. So hello world, and then we have the char destination with space for, let's say, I like to put in like 15 to keep it short. And then let's see if this function is working as we want it to. So ft str ft str copy destination and str return 0 hello world. There it is. Cool. Again, remember I'll say on the start of the videos, I just won't be doing this because it's too much of a hassle for me, but we have to make it a comment because the Molinet doesn't allow main functions. Oh, I forgot the exercise 01. Now going to exercise 01, ft, str, and copy. It's interesting. Vim ft, str, and copy.c. We include unitd and we include @cdio. Char pointer ft, str, and copy, char destination, char source, unsigned int n. You don't really need to care about unsigned int right now. It is basic minutes. But if you're too curious, we can look up. So we have to we reproduce the behavior of the function str and copy. So let's see what str and copy does. So this function copy no bytes from the starting point to from the string pointed to by source into the array pointed to by dest. If the source has too few non-null bytes to fill the destination, the function pad the destination with trailing null bytes. If the destination starts enough, it's truncated an implementation of this function. So here we get the len, str len, then size, and we return the destination. Str and copy returns a pointer to 1 after the last character in the destination character sequence. So we have basically nothing with this, but since I did my research, and you can do your own too, str and copy basically will do the same thing as str copy, but the end character means that it will be for an n amount of characters. So if we have our phrase, for example, hello world, but our n is just 5, then it will only print hello, and it won't print hello world. Cool. So how do we do this? We start in y, I equals to 0, and while source of I is different from no. But the trick here is that we need to declare another condition on this while, and we do this by adding the e sign, which is the shortcut for n, and I is smaller than n. So the destination of I is going to be the thing as the source of I and I plus again. We again say that the destination of I at the end is equals to no, just to make sure everything is working fine, and we return the destination. So if you already guess, if our I is 5, our source is hello world. Our I starts with 0, but it will reach 5, and it will reach 5 on the O. So after HELLO. So right here it will be 5. So since I is not smaller than n, we'll just print hello. I hope you understood the logic right here. So we go to our main function again to see if everything is working fine. The source is hello beautiful world. And then our death char has 25 characters, let's say, just because the phrase bigger, but our int It's just 5, 6, like 10, I guess, something like that. So let's see if we didn't mess up. Well, that starts in oh my god. Okay. Hello, BL. So this is 10 characters if you count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pretty cool. Again, make it a comment, etc. You know. Now, exercise 02. Here's where the nightmare begins, because it will be a bunch of functions basically doing the same thing. And this is pretty boring. So I'll explain deeply this first one, and then the other ones I won't explain really a lot. I'll just keep going and talking kind of fast. So we include unistd.h, and we include stdio.h as well. Our int ft str is alpha, str pointer to str. So create a function that returns 1 if the string given as a parameter contains only alphabetical characters, and 0 if it contains any other character. Here's how it should be prototyped. It should return 1 if str is empty. So again, you already know I is equals 0. Okay. So first thing, let's just make sure this case is completed. So if str of I equals to null, we will return 1. Now, yes, we can work on this part of the code. It returns 1 if the string contains only alphabetical characters. Well, if we go to our ask table right here, we can see the alphabetical characters are the uppercase A to Z and the lowercase from A to Z. So, while str of I is different than 0, so let's say if, and I'll explain why this is different here. If str, well, basically, no, I'll explain right now. This exclamation mark right here means the opposites, and we will understand it shortly. So, if str of I is, again, this is the negation, so is not equals to positive A, and str of I is equals to Z, or this is the or str of I is greater or equals to small a, and str of I is equal of Z again, it will return 0, and the function itself return 1. So what are we doing here? Well, here we're just taking care of the case on str I being equals to null or empty. Now, while str is basically existing, so while str exists, so if str being I'm sorry, I messed up here. Okay, so while str is greater or equal than the bigger A and the bigger Z, so it's all the uppercase alphabet. If it's not, because we have the exclamation marks here, if it's not all the, if it's not, oh, I mean, if it's different from A to Z uppercase and it's different than A to Z lowercase, we will return 0, and then we will return 1. And now we check our function to see if it's working. So char str equals hello guys, So yeah, you can pause the video to get what will return. But anyway, so we have our uh, percentage of the break line, FP, STR, alpha, STR, pum pum. Let's save it, let's compile it. Which mistake did I do? Expected. Oh yeah, I didn't close my parentheses right here. What else? STR 0. Oh yeah, I wrote STR. Oh. In printf, there is a star right here. There's a lot of mistakes in this code, but okay, so something's missing. Oh yeah, damn, I really messed up on this code. I plus here because we have to iterate to make sure the function is working. There it is. So it will return 0. Why did it return 0? Because on the string hello guys, there is a space right here. And since space is not an alphabetical character, it will return 0. Now that they're all together, we have our 1. So I hope you understood this concept of, well, is it, if it's different than A to Z uppercase and A to Z lowercase, it will return 0 because it's not what we want. And now we will basically just do the same thing for the next like 3 exercises. I really hate it. See, C02 is low key the worst ever. So when FD STR is numeric, dot C includes union.age, include sdio.age. So again, I have created a function that returns 1 if the given string as a parameter contains only digits, and return 1 if str is empty. So let's go ahead. Int ft str as numeric, str. So we have our y I equals to 0. So if str of I equals no, well, we'll return 1. Equals to 0, return 1. While str of I go like this. If different str of I being greater or equal than 0, and str of I being smaller or lesser or equals than 9, we return 0. We do our iteration through I++, and we return 1. And we return 1. Now our main function right here, str is equals to 1 to 3, a bunch of random numbers. Then printf, percentage of d, and fd str is numeric. Then I have our str right here. And it will return 1, but if we put in space or a bunch of characters right here, we can see that it will return 0. So let's go to exercise 4. Now, fd str is lowercase dot c, and include sdio.age. In fd str is sorry, lowercase char str. There we go. So I equals to 0. Oh yeah, and by the way, this function returns 1 if the string given as a parameter contains only lowercase alphabetical characters. So if str of I is equals to no, we return 1. Now that I say it, we don't need this part of the code because we are already returning 1 anyway. Well, while str of I is different than no, if str of I, the difference my terminal is not, oh, okay, thank you. str of I is between A and str of I, and then lowercase z, we return 0, iterate, and we return 1. So we have our character right here. Hello. And then we print percentage of d ft str is lowercase str. And then we have 1 if we put a capital character here. We notice we have 0 as a response. But this is working just fine. Exercise upcase. And exercise is 0, 5. I'm sorry. So in ft str is uppercase dot c. We include unisd. We include stdio. dot h. Int ft str is uppercase. Char pointer to str. Again, return 0. I just realized we don't need that code. I was being stupid. Returns 1 if the string given as a parameter contains only uppercase alphabetical characters. So I is equals to 0, while str of I is different than no. If str of I is if the difference, okay. A and str of I then are equal. Then capital Z, return 0, I plus plus, and we return 1 again. Our main function, let's test it out. Print f percentage d and ft str is uppercase str. What? Okay. Okay, here we have it. We have 1, and then any other lowercase character, we have 0. Now, str is printable. This is tricky. This is funny. This is the most interesting one. So let's go to exercise 06, and we're going to do something funny. str is printable.c. include unisd.h, include scao.h. Int ftstr is printable char str. So create a function that returns 1 if the string given as a parameter contains only printable characters. Now, we can easily do this, but we cannot create a main function for this to actually test it out. And we'll understand why. Because on our ask table right here, all the non-printable characters are 0 to 31 and the character 127. Well, why can't we test the code? Because we cannot write this on a string, so we can't test if the string is actually working. But there is no problem, because we can just do something like this. Well, we have I is equal to 0, while str of I is different than null. Now we'll actually use the ask table. So while if str is different than greater or equals than 32, so it would be space here on the ask table. The 30th second character is the space, and str of I is lesser or equals than 126. Or if you wish, you can do like this and this. But since we are using the ask table about non-printable characters, I just prefer using the ask table itself. If it's not this, we return 0. 0, we iterate, and we return 1. And we cannot test this function because, again, we can't write non-printable characters on a string. So let's go to exercise 7. Create a function that transforms every letter to uppercase. So this is easy. So then ftstr uppercase.c include units.h includes scao.h. I have char a pointer to ftstr uppercase char str. Since I equals to 0, and while str is different than no. Oh my god, again. So, how could we possibly convert a lowercase character to an uppercase character? Let's go to our ask table, and we will realize something. So, the uppercase A is equals to 65, and the lowercase a is equals to 97, meaning there are 32 characters from difference between them. So what we're going to do, since a, the string of a is equals to 97, they're the same thing. If we subtract a certain amount of 97 to get to 65, which is 32, so 97 minus 32, we'll have capital A, capitalized A. So basically we do is if str of I is the lowercase alphabet, str of I, what we're simply going to do is reduce, so minus equal 32. then we will be removing 32, and the sign minus equal is the same thing as, this is the same thing as writing str of I is equals to str of I minus 32. This is just a shortcut for us to not write that much. We reiterate and we return str. So we go to our main function, we create a char. This is all pretty cool. So I mixed lowercase with uppercase, percentage s from sentence, str uppercase, return 0. Yeah, I didn't. Yeah, from str. Okay, this is all pretty cool, huh? You can see this is all in uppercase. Now, the lowercase is the same thing, but we'll change the sign right there. So, exercise 08, let min ft str lowercase. Let's see. So, char ft str lowercase char here I equals to 0, while str of I is different than no. If str of I is like the big A, well, the big alphabet itself, instead of subtracting, what will be adding. Of I plus equals 32, I plus, and we return str. Main function, test it out, compile, see if everything is working. Lowercase, but this is pretty awesome, isn't it? I just wrote a big ass phrase, but anyway. Printf percent sentence ft str low case str. Let's compile it. Lowercase, but this is pretty awesome, isn't it? Everything is in slow case. Now, here, I'll just get my sheets right here, because this code is pretty hard. So, first we need to understand what we need to do. In ft str copy .y.c include unistd include stdio char pointer to ft str capital Y char pointer to str. Create a function that capitalizes the first letter of each word and transforms all other letters to lowercase. And what is a string? What is a word? A word is a string of alphanumeric characters. Alphanumeric being from big A to big Z to small a to small z and 0 to 9. Anything other than this thing right here is not a word. Here's how it should be prototyped. It should return str. For example, now I have a cool example. Salute, comment tu vas? I don't speak French. My pronunciation is probably terrible. Oh, hello, how are you doing? We can see that it becomes salute because this is capitalizing basically the first letter of every word. For the two mods, this M right here is not capitalized. Why? Because there is a number here, and you can think that this word here is capitalized. Think of this word as capitalized. 42, 51. Why? Because plus is not an alphanumeric character, so obviously this is basically counting as a space. So what do we do from now on? Well, first we do I equals to 0, while str is different than no. So the first thing we're going to do is that we are going to transform all letters to uppercase, because then we'll just need to make the rest of the letters smaller case. And you can do quite the opposite. It's just that I got used to doing like this. I've already done this function like 4 or 5 times already in a period of like a month. So str have to if, right, if str of I is equals to a and lesser or equal than z, str of I minus no plus equals 32. Now everything is going to be a smaller case, and now we will have to do something cool. If I is equals to 0, so the first position of I, because this is basically an array, right? This declaration turns an array and turns this into an array. The position 0 is the first thing that's going to appear. So while str of I is, oh, I'm sorry. Wow, the difference. So if str of I minus 1, and why are we doing this minus 1? We are calculating the position beforehand the character we are currently working. So for example, let's take comment as an example. Well, if I is equals to the position of C, we are subtracting 1. So we are actually counting this character right here, which as we know is a space. On the 42 mods example, this M right here, if the I is on the position of M, but we just need to count all of here, but not feeling of doing it right now, the character beforehand is 2, and since 2 is an alphanumeric character, this M right here will not become uppercase. So if str I minus 1 is greater or equals than a, and str of I is lesser or equals than z. So if it's different, I forgot to add parentheses here. Well, if it's not I'm sorry, it's kind of confusing. So if it's different than being lowercase, and then I'm just doing this syntax right now because the compiler, or if I'm not mistaken, the Norminet doesn't accept for us to write like a very long line of code like this. It wants us to keep it short and clear. So that's why we use spaces right here. str of I is from A, str of I within Z, which is all the alphas, and I'll have to handle the numeric. So str of I, then 0, and str of I is not lesser or equal than 9. Well, if it happens, what are we going to do? Well, if What am I missing? There's something wrong. Hold up. I see it. Okay. So, and if all the characters beforehand, those. So, if the character beforehand is not an alphanumeric, and if the character after the alphanumeric, so if str of I is a small character, well, we'll just make str of I capital. So I hope you understood. So here we transform every single character on lowercase. Now we will say that if the character, oh damn, I forgot to add the -1 in all of them. -1, -1, -1, and -1. So if the character beforehand then is not alphanumeric, and if the character after the non-numeric character is a lowercase character, we'll just make it a big character. And then we iterate it all, and we return str. So let's test it with their own example is equals to copy as in fd str capitalize str, we return 0, and we see that our code is just like there. Saludos, como é que va? 42, etc. 42 mods, 42, etc. etc. This one is a little bit painful to do the first time. You have to think a lot and understand. And now we go to our final exercise. Finally. Exercise 10. ft str l copy. So it just needs to reproduce the behavior of str l copy. Let me just get my... Oh, okay. str l copy. .c. We include unifd. H, we include fdio.h, and sign in ft strl copy, chart dest, chart source, and sign in size. A lot of stuff to write. So mem strl copy. Let's see what it does. Let's search for strl copy. I already know what it does, I'm just trying to get the actual thing itself to explain it to you. strl copy. Okay, we copy and concatenate the input string into a destination string. If the destination buffer, limited by its size, isn't large enough to hold the copy, the resulting string is truncated, but it is guaranteed to be null terminated. They return the length of the total string they try to create. So what does it mean? It means that we'll have a string saying, I don't know, what's up, programmers, and then our destination buffer is just 7, or it can be 70 as well. What the strl copy will return is just the necessary size for us to have in order to actually display this string right here with no problems. So we will not return the string, we will not return the destination, we don't really return anything, we just return the amount of size necessary for this string to work as intended. So we have our I function, I is equal to 0. But in our case, we'll also use a j, not j function, a j variable, and j is also equals to 0, and we'll understand why shortly. So while source of I is different than 0, we'll simply just say I plus plus. I plus plus, what am I missing? I, right. It's basically I plus plus, and we will understand why this I plus plus is here, but anyway. So if size is equal to 0, so if the size is equal to 0, we will just return j. And j, on our case, is going to be the necessary amount of space we need. So j is equal to 0 in this case. So if size is equal to 0, it means we need no space because there is nothing there. But while source of I, which on our case it will be anything depending on the size of the string source, I plus j, which in this case is 0, is different than the no terminator, and I is lesser than size minus 1. Again, this minus 1 here is just to cover the array issue where the position 0 is the first value, so we use minus 1 to basically fix this problem on 0 and 1. Well, the destination of I is the same thing as the source of I, and we do I plus plus. Now the destination of I is equal to no, because we read it, it should be no anyway, and we return j. So as we see, where is it? Oh, I'm really sorry. Yeah, I just messed up. I just looked at the correct codes. It's j plus, no, it's just I. I'm stupid. Let me just check to see if I'm not. Oh, yeah, okay. Yeah, I'm goddamn stupid. So if the size is 0, it will return just the size of j, and then we have a source of I. We'll basically just calculate the destination. Okay. So let's see an example to explain better this for you. Hello, people from Earth. And then this is our shard source. And then we have our destination, which let's say it has a 50 buffer size. Unsigned in size, let's say it's equal to 17, just because. And now we'll print percentage d ft strl copy, and now that's source and size return 0, and we would need at least 25 characters of space, which we do have. We have 50, but anyway. So let's get to this string. We have hello people from Earth. So this is the source. So while source of j is different than no, so we will iterate j. So j will be the amount of characters we have here, which in our case is 24. So j is 24. If size is equals to 0, we will just return 24. Why? Because we don't, since the size is 0, we won't need to actually iterate the destination here. So while source of I, this is just to actually copy the thing. If we wanted to, we could just copy this here. And then we just make sure the destination is a finishing with a no character, and we return j. So yeah, that's it. If you want to do exercise 11 and exercise 12, you can. But again, with everything we did until now, you are able to do exercise 11 easily, and 12 if you just want to lose your minds. Yeah, that's it. See you in C03.